Let's want to review Python. You find that Python, having done Python first helps a little bit?
Yes. I picked a good program to learn.
There's so much, there's a lot of extra stuff to make it.
This is a really good book. This Barbara Johnson book.
Yeah, she's
It's great.
she was an instructor here and became an associate dean. She retired last year. She may come back. I don't know. It'd be nice if she did. She was a really good instructor too. And a really good associate dean.
During this Python.
Yeah, y'all were talking about it, and I was just thinking, about 2 or 3 days ago, I finally became comfortable with Python. Like, I felt like everything, like the first like 3 weeks of the course, like, this can't be right. This is just so, like, clean, like, it's just too, like, I'm missing something.
Yeah, there's more thrash. It should be more thrash that you're. Have you programmed other languages before?
So I started programming in C. From C, I started learning Bash, Perl, and then I did some C++, like Java.
Okay.
I'm very used to the granular detail of the design, that having to worry about all of that. But like the thing is, like, so like with Bash, it looks really ugly, and so does Perl, because like they're just so old. But like this one, I think part of the big reason why I thought I was like something's wrong is because just the way it looks. Like I don't see a lot of what, like, to me seems like a scribble, all these scribbles that you might find it. Just the way that the script language looks, older languages as opposed to this.
You used to like looking through a lot of syntax to find the intent, whereas Python maybe it's just intent. In many ways. But yeah, it's interesting because it's like it's a very declarative language in that you can write a lot. You can get a lot done just by writing an expression. It just does it. But I think it also there are other things that become harder later on because you don't have quite the you're not controlling types and your errors are all runtime errors by definition. So your the maintenance issues are tougher. But I kind of think like if someone's had a little bit of experience programming, then going straight to C++1 works. If you haven't had anything, going through the Python first might be a way to cut down the complexity a little bit.
That didn't really help me. I think I would have been lost.
Yeah. Well, I mean, yeah, and people pick it up at some point. I think there's like an epiphany type thing. But I don't see like there's a procedural, structural way of, okay, you do this, you do this, you do this, and then ta-da, you understand programming.
You have to get your hands dirty.
Yeah.
You're going to be the only one in class today.
Yeah, I guess are we there? Yep. This is attend anywhere, so we actually I have 6 students online.
Oh.
Hello, can everyone hear me? Cool. All right. So today, see, we already did this part. So today we're just going to kind of work together to build a program together. So it's going to be interesting. I've never done this with Attend Anywhere. So we'll see how it works. So I might have you, let me see, maybe if I make everyone, oh, so we'll get to that. So there you go. If I have, so I'll probably have you like suggest code as, you know, by typing it into the message box as we go. But what we're going to do is we're going to make a mortgage payment calculator because if you learn any programming course, it's like you're contractually required to make a mortgage calculator at some point. And so the formula for calculating a mortgage is the following. M is equal to P times I divided by Q times the result of 1 minus the result of 1 plus the result of I divided by Q, 1 plus that being raised to the minus NQ power. So the reason why we like using mortgage calculators is their complex formula. And if you can solve this formula in code, or you can translate this formula in code, you can pretty much translate any formula in code. It could be the future value equation, could be the two-body force equation from physics, and so then so it's a good formula to kind of play around with. So we're going to make a little. Let's say we have this requirement to build a program. It's going to have a do another loop, and we're going to ask the user to enter the amount borrowed, the interest rate, and number of years of the loan. And we're going to do that with some ask functions. So we're going to make we're going to use this with functions to get the results back. And you know, one thing to note is when we ask the users for their interest rate, we have to be clear to the user whether we want them to put 5 and a percent sign, or just the number 5 or 0.05. And so it's important to control the user with your input statements. And then once we have the user input, we're going to call a mortcalc function, which will take the principal of loan, the interest rate in years as a parameter, and we'll calculate monthly payment, total money paid over the life of the loan, the total interest paid over the life of the loan, and then return that in a nicely formatted string. So the inputs will be loan, interest rate, and years, and principal, and then the output will be a string with all that information. And so to examine the formula more closely, M is monthly payment, I is interest rate, P is the principal of the loan, N is the number of years, and then Q is the number of payments per year. So we might just assume that's 12, or we might ask the user for it. We'll see how it goes. And so we're going to program this as a group. So I'm going to open up idle. And we'll give it a few seconds to spin up. And I'm going to save this as mortcalc. Did we do this? We didn't do this last time, did we? Okay. And then okay, so oh, we did do this last time? Ah, so maybe that's why I have mortcalc sitting there. Okay. Oh, okay. I'm going to move on to the next presentation then. I lost track of where I was at. I'll run through it with you if you need to. Yeah, I'm not going to do the Py demo here today. I'm going to move on with I had that in there because last time I was on leave, and and actually I may have, and we had someone who came in and did the Py demonstration. I might pull one in at some point and show it. But we're going to continue on then and talk about functions. No, there's no demo for that. It was actually using the Raspberry Pi, demonstrating what the Raspberry Pis was. And there's a course called CIS 1605, which is Internet of Things. No, that was just a demonstration. And sometimes what I'll do is I'll do a program together just so that people can kind of see the process I go through when I make a program. Okay, so then today we're going to talk about parameters. And so write this program. Define hello1, which is going to take two parameters, greeting and name, and print greeting and name in %s, and then define hello2, which is going to reverse these parameters and make name and greeting. And then we're going to call hello1 and pass in hello world, and we're going to call hello2 and pass in hello world. And what I want you to do is, before you run that, is predict what order hello world will come out in hello1 and hello2. And so online, type out if you think that they will have the same result or will have different results with these two functions. We got one vote for same. But they both say, one says greeting name, the other one says name greeting. Shouldn't it be different?
Should be different. The parameters that one of them starts with whatever greeting is, and the other starts with name.
Go ahead and run it and see what you get. They come out the same. What's happening here is, notice, so let's look at hello1. Which parameter does hello go into? It goes into greeting. Yes, correct. So if it goes into greeting, what gets printed first in hello1? Which would be hello. So we get hello first, and then we get world. Now let's look at hello2. Which parameter does hello go into in hello2? Name. And name gets printed out first. So again, we get hello gets printed out first, and then world gets printed out second. See, the thing is that the computer doesn't actually read your variable names in the sense of like it reads it and then understands what name is and what greeting is. This could be Larry and Curly and whatever. It could be any value, you could come up with any identifier. All it's doing is it's taking the arguments in the function call and placing the first argument into the first parameter and the second argument into the second parameter. And since in both cases, in hello 1, greeting is the first parameter and it's printed first. And in hello 2, name is the first parameter and it's printed first. They both will have the same result. So does that make sense? So now, and that's going to be something you fight as a programmer all the time. Your mind is able to jump to conclusions really, really fast, but the computer does everything literally. So let's try this. Let's add another series of function calls, and we're going to use something called keyword parameters. And what keyword parameters are is, notice that when we made this function calls before, we just placed the arguments into the list here, just in order. What we can do is we can use a keyword parameter which says, in this hello 1 call here, it says, hey, set hello into greeting and set world into name, and then run the hello 1 function. In the second one, we're saying we're going to put world into name and hello into greeting and run function 1. And then in hello 2, we're going to put hello into greeting and world into name and run hello 2. So make these changes to the code and then try to predict what you'll get.
Okay.
The first two, the last one.
Yeah, so does everyone get hello world, hello world, world, hello? And Bethany, can you hear me? So let's take a look at, I wasn't speaking for a little while there, Bethany, I was letting people type. Let's take a look at what happens here. With the keyword parameters, basically, it's kind of like rather than just placing the parameters in by, or the arguments in by position, you are telling the function where you want them. So hello, in this case, is going to go into greeting. World is going to go into name. And that kind of does the same thing as it did last time. So you get hello world. Now in the second call, even though we switched the positions, because we're telling it which specific parameter we want to go into, we can see that world is still going into name, hello is still going to greeting, and therefore you get the same result. That probably makes sense. In this one, we're calling hello 2, and we're putting hello into greeting. So which parameter does it go into? The first parameter or the second parameter? Second parameter here, right? And so hello goes into greeting, and does it get printed? Does greeting get printed out first or second? Second. And that's why you get world hello. Does that make sense to everybody? Yes. Yeah, and basically what the skill is a lot of times in debugging is just being able to trace where things are going. And the part of the key of that is slowing down. A lot of times I've been writing code, I can't figure out what's going on. So what do? I read a little faster because I'm in a hurry, right? And then I don't find the answer, and then I read a little faster. And then I don't find the answer, and then I read a little faster. And what we really do is we slow down, and you got to like take each individual piece and match it up and see what's happening. But keyword parameters are going to be handy for a couple wereasons. One, let's look at these two function calls. Here's store we're calling store. We're passing in Mr. Brain Sample 10, 20, 13, and 5. So what's 10, 20, 13, and 5? If we just read that line of code, it's not very obvious. But if we use keyword parameters, it's kind of obvious what each one of these are. So you could argue that the second format here, using keyword parameters, is a much better way of writing your code because it's clear what's happening. And so never wrong to use keyword parameters, but it does take a little bit more to write those in. And some code editors allow us to hover over the elements and it'll tell us what the parameters are, but you can use keyword parameters. So hold on to the thought about keyword parameters, and we're going to look at default parameters. So try that, right? You can add this to your existing program and call it or put it in a separate program, but define hello 3. And in hello 3, you're going to say greeting equals hello, name equals world. And so this is different because now we're putting these assignment operations in the function definition. Before, with keyword parameters, we had these assignments in the function call, and they served as a way of pushing parameter arguments to specific parameters. In this case, when you use default parameters, what this is saying isn't greeting will be hello every single time. What it's saying is if when you call this function, if you don't pass me anything for greeting, use hello instead. And if you don't provide me a name, use world instead. So these are what are called default parameters, because if it doesn't receive an argument for greeting, it will use hello. And if it doesn't receive an argument for name, it will use world. And so now we have 4 function calls, and tell me if these work. So write that code and run it. And try to predict what it's going to output for each one of those before you run the program. Okay, so if we run that, what you should get is we get hello world in this first function call, but we didn't pass anything in. And what it does, it ends up using these defaults. So because there's no parameters passed in, no arguments passed in here, it says, well, then I'll use hello for greeting and I'll use world for name, and it says hello world. In the second function call, we pass in greetings. Where does it put greetings? Well, it's not a keyword parameter, so it's just going to put it in the first parameter. So this argument, greetings, will go into the first parameter, which is greeting. But then we didn't provide name, so it's going to use the default for name, which is world, so it says greetings world. Does that make sense? In the next one, we provide both parameters. In the next one, we provide the same two parameters. And this really just works like a regular function call. It puts greetings into greeting, puts universe into name by position, because they're not keywords. And then it says greetings universe. Now the last one, what we do is we have a keyword parameter. And this is where the power of combining both default parameters and keyword parameters comes in, because it used the default for greeting, but then it said, hey, put Gumby into name. So it says hello Gumby. So where the power of this comes in, and when we do GUI programming, it's going to be much more apparent, because if you define a text box, well, there could be like 15 different parameters for the text box: where it's located on the form, how wide it is, how high it is, whether it allows multiple characters or not. When you put all those parameters together, there's a lot of them. And if you had to set every single one of those parameters every single time you declared a text box, that would be problematic. But by using keyword parameters and default parameters, they set a bunch of defaults for those text boxes, and you only have to set, using keyword parameters, the things that you really want to change, that is, aren't the defaults, and it makes it easier to use your code. Let's make hello 4. It's going to have a required, we call this first one, we call regular parameters actually required parameters, because there's no default. So it's going to have a required parameter for name, a defaulted parameter for greeting, which will default to hello, and a default one for punctuation, which will default to exclamation point. And then we're going to make these 6 function calls. So go ahead and write those, and then try to predict what the output will be for each one of those, and then hit enter and run it. Yeah, Antonio, notice that the parameter list in the function brings name and then greet, but in the print it will say greeting, then name, and then finally punctuation. So there's a swap there in the print statement. So if we run this one, what we notice is that we get hello Mars. So looking at this kind of makes sense. Mars goes in the name. The default for greeting is hello. The punctuation is exclamation point, and you get hello Mars exclamation point. In the second one, we're passing in Mars to name, howdy to greeting. So we get howdy Mars and the exclamation point. Notice that greeting is printed first and name is printed second, even though they're reversed in the order there. Then we get howdy Mars and 3 ellipses. So this last one actually provides a argument for every single parameter. And so we get howdy Mars and ellipses. The fourth one, we pass in Mars for name, and then we use a keyword parameter to put in a period to replace punctuation. So then we get hello Mars and then a period. And finally, or second to last, we get Mars, a keyword parameter saying greeting equals top of the morning to you. You hardly need to use this keyword parameter because it would go in anyway, but maybe they want to make it clear. And so you get top of the morning to you, Mars. And then this last one, why do we get an error on this last one? Hello for missing one required positional argument name. Yeah, because name, notice how name doesn't have a default, right? So if we put an empty parameter list, it's going to say, hey, I need something for name and you didn't provide me anything. And then it just yells at you. Does that make sense online? No, it's not even considered null because it could actually handle a null coming in there. It would just then display a null for that position. It's actually literally saying, I need something to come to that parameter, and I'm going to get an error. You could actually say hello for null, and it would actually run, and it would, or empty in the case of Python. But you could pass an empty, and it would probably say something like hello, and then nothing, and then punctuation. So that was default and keyword parameters. Any questions on default and keyword parameters? So the next thing I'm going to discuss is scope. And one of the things to understand is when you write programs, when you declare variables inside of Python, the variables only exist within the scope they're declared in. And so if you declared them at the main level of your program, they'd be available to anything within the main level of the program. If you define a variable inside of a function, they're only visible inside of that function. So there's this neat function we can use to see what is in scope. It's called the vars function. If you run the vars function, it'll tell you wherever it's running at what variables are visible. So try this. Write a program that defines my function, and we'll set a equal to 3, b equal to 4, print x, and then it'll try to print x and y. And then you'll, inside the main part of the program, you'll say x equals 1, y equals 2. It'll call my function, and then print a and then print b, and see if and we'll see what comes out. And then run that and try to predict whether it will be able to display x and y and whether it will be able to display a and b. It won't display A and B because it is out of scope. And yes, in fact, that's what you should get. You should see we get x equals 1, y equals 2. We call my function. They've been declared, and the function can actually see 1 and 2 because the function is within the scope of x and y. But if you try to print A and B, even though my function is already executed and 3 and 4 are set into A and B, you can't print A and B because the variables you declare inside of a function are only visible inside of the function. Why do we want that? Why a good thing? Yeah, and that's kind of called the namespace problem. Is, if every variable and every function that was ever, and every library that imported, was there, we would have to deconflict all of our names, right? So rather than A, it'd be variable A declared in my function, written in a program by Rob, that, et cetera, et cetera. You'd have to have these really long variable names just to deconflict them. The other thing too is that the variables, after you get out of a function, go out of memory. They get garbage collected by languages like Python. And so they also minimize the amount of active memory or RAM that you're using up at any given time. And it's a memory saving function. And if programs today or computers today have quite a bit of memory, but there was a time when the memory was very limited. And so very early on, they needed to find a way of only having in memory the variables you need for the function that you're currently executing. And so that's why you have scope.
So maybe because I did this wrong, I type in bars now after typing that illustration, nothing comes up.
Oh, you mean from the previous demo?
Yeah, this one where we did the function, the scope demonstration that we just did right now.
Yes.
After I type in all that, I type in bars, enter, I don't see anything where it's the value show up.
Let's see. Actually, do I even use vars anymore? I don't think I'm using vars anymore in this demo. I should probably hide that slide. But if you put vars inside of these functions, it should do what's visible at any given time.
Okay,
If
I did was I typed in bars.
Like at the command prompt?
Yeah, the command prompt. I did it once without the open close parentheses, and the other time with the open close parentheses. Without open and close parentheses, it just says built-in function bars. The other one actually just dumps up a bunch of.
Yeah, because without the parentheses, it doesn't recognize that you're not running the program. And so it tells you what that thing is, which is a function located placed in memory. So yeah, so you can put vars inside of my function and vars outside of the function, and it'll tell you what's visible. So that's scope. Any questions on scope? Okay. So there are ways to get access to variables outside function scope, and they are described in your book. However, you rarely, if ever, need to. In fact, for this course, I'm going to ask you never to use global variables. And I have not found in my life a lot of good reason to ever use global variables. Usually I could figure out a way of passing things into constructors and functions in order to get access to things I need inside my functions. So I don't recommend using global variables. They sometimes seem like they'd be convenient, but they can potentially create problems because you never know what may change the global variable. Like one function may be called, and especially if you're doing asynchronous type of programming where you maybe have multiple functions are running all at once, have your global variable changed in the middle of another function's run, and so it can create some weird problems. So generally speaking, you want to pass things into a function, have it deal with those things, and then just return whatever you want to get out of it in the return statement. So, reviewing what we discussed, the term abstraction is the art of hiding unnecessary details. You can program it more abstract by defining functions that handle details rather than doing the whole program all in one big long main section. If you can imagine like trying to make a really complex program where it's all in just one big long, program, it would be impossible to maintain. So we use functions, and later on we'll even learn how to take our functions and put them into these things called classes, and then create libraries to store everything, so that we try to break everything apart into more abstract groups. And so at the top level, it's not unusual to see a program that just says run program, and that's the top upside level, and the run program function starts parsing things out to different functions that do all the different pieces. So the abstraction is how we make really complex things simpler. We looked at parameters. We had, that we learned how to use keyword parameters and default parameters, and when you put those together, they make it easier to make your function so that you can call them and let all the defaults run, or you can set different individual parameters, and you only have to set the parameters you want. And then we talk about scope, and that the variables really only exist inside of the tab level, if you think about it, because when you write a function, you tab in. The variables only exist in that block of code which is tabbed in. So in Python, we say that the variables are actually block scoped. So any questions on any of the material I presented online? Then let's take a look at what our current assignment is. Did we go over the current assignment? Program 6. Yeah, so the next one is going to be program with functions. So we're going to start, and this is going to be the start of a program that we're going to be doing, we're going to actually be using and reusing. So we're going to write a program that calculates the distance between two geographic points. The thing about geographic points, though, is that they're in latitude and longitude. And so you can't just use Cartesian type calculations, like the Pythagorean formula to calculate the distance between two geographic points. You actually have to use something called the Haversine formula. And so you're going to make a program that's going to have three functions. A header function that takes no parameters and returns nothing. It just displays a header. So it basically is just a print statement in a function. And then you're going to do a get location function. And what this function will have no parameters, but it's going to ask the user for latitude and longitude. So you're going to do two input statements in this function, and it's going to take the latitude and longitude it gets from the user and return a tuple that will have the latitude and longitude in the tuple. So the first element of the tuple should be latitude, and the second one should be longitude. And make sure that you tell the user what units you want the latitude and longitude in. And what we're going to ask for is decimal degrees. So latitude and longitude are basically angles. Latitude is is angles around the Earth, and longitude is the elevation, the equator, or declination from the equator. So you could ask for degrees, minutes, and seconds, but that would be painful. So I'm going to suggest you use decimal degrees instead, which is a single number rather than three numbers. And then you're going to make a distance function that will take as parameters two tuples. Each tuple will have a latitude and longitude, which will be the location that you're going to measure from and to get the distance. And the Haversine formula is as follows. Given latitude in decimal degrees, longitude in decimal degrees, and the radius of Earth, Well, actually, it should be in radians, not decimal degrees. So you're gonna have to turn these latitudes and longitudes into radians, and then you can use the formula. Well, actually, it would work with this, except that Python's sine, cosine, tangent functions take radians. So you're going to have to take the latitude and longitudes and convert them to radians to pass them to the sine, cosine, and tangent functions, or atan2 function that's in the Python math library. And when you do that, basically what you do is you take the sine squared of lat1 minus lat2 divided by 2, plus the cosine of lat1 times the cosine of lat2 times the sine squared. And this sine squared is basically just take the sine and then square the result. The sine squared of longitude 1 minus longitude 2 divided by 2. So that's the first term you figure out, store it in A, and then take the arctangent 2, which is a function of the square root of A and the square root of 1 minus A, and multiply that by 2 to get C. And then if you multiply the radius of the Earth times C, you get the distance between those 2 points. So that's the formula you need to make in Python. And once you make that formula, then the main part of your program is going to do the following after you declare your functions. Call the header function and display the header. Then allow the user to do multiple calculations. So I would program my do another loop at that point and just test your do another loop and make sure that that works. Then once you have your do another loop working, inside that loop, call the get location function, and you're going to call it twice. And so you're going to say something like 0.1 equals get location, open close parentheses, and then 0.2 equals get location, open close parentheses. So we're only going to write one get location function, but by calling it twice, we'll get 2 points. So this is illustrating the fact that with one of the things you can do with functions is if you have something you need to do multiple times, define it in a function one time, and then just call that function multiple times. So you shouldn't have a separate get location function for 0.1 and 0.2. They should both be gotten by calling the same get location and storing them in 2 different variables. Once you can get the location in those 2 variables, you could just print them temporarily just to make sure it's working, then delete those print statements. At that point, then you pass those 2 points to your distance function. And your distance function is going to return the distance, and so store that in the variable as well. So you're going to have something like, dist is equal to distance, open parentheses, 0.1 comma 0.2. And once you have that distance function, then that distance back from the distance function, then you're going to display a nicely formatted print statement to the user telling the distance between your 2 points is, and then the distance. And then you ask them if they want to do another, and they can do another calculation. Essentially, this is a calculation program. And to test your program, you can get the latitude and longitude for Albuquerque and for Santa Fe, and use Google Map, and you can use Google Maps. And Google Maps will actually tell you the distance between 2 locations. So you can do a measured distance. And it tells me that's 56 miles. So then I can look up the, if I say what's here, Albuquerque gives me the latitude and longitude. If I click here, I'm right clicking. And do the what's here on Santa Fe gives me latitude and longitude. So I can pass in those latitude and longitudes and see if it ends up at 156.56 miles. So using that tool, I can then validate that I can validate that my program is getting the right results. And then some hints. Get location, it should look like something like this. 0.1 equals get location, 0.2 equals get location, and we'll return a tuple that looks like, lat, comma, lon. And then the distance will look like something like this. You pass in 0.1 and 0.2 to your distance function, and you get a distance. And that's what that part of the code should look like. Any questions on the spec? Can everyone hear me online? Okay, good. So some other hints, there may be actual formulas out there or programs out there or snippets of code out there on doing the Haversine formula. I'm fine with you referencing those. Just put a comment in your code referencing that. You'll probably have to modify them if you access those, because they will not have inputs quite the same way that you need them. They calculate things exactly the same way. So you feel free to look stuff up and provide references, but when you do, be careful how you implement it in your program. So sometimes implementing other code is can add some errors if you're not careful. But you're fine to do that, but make sure you reference the code you're using. And some of those are in other programming languages, so you can translate it over from the other language into Python. You just have to find the equivalent syntax. So, any other questions on the spec? Then that's all I have for today. The rest is lab time. Thank you very much.